Hello everyone, you're welcome to solve this nice exponential problem here, which is 5 to the power of 1 plus x plus 5 to the power of 1 minus x. This is equal to 26. So what is the value of x here, given that x is not equal to 0? So let's prevent the solution from here. We have 5 to the power of 1 plus x, then plus 5 to the power of 1 minus x. This is equal to 26. Now, you find that 5 to the power of 1 plus x, this is in the form of a to the power of n plus m, which we can express as a to the power of n times a to the power of m. Now, 5 to the power of 1 minus x, this is in the form of a to the power of n minus m, and this can be expressed as a to the power of n over a to the power of m. Applying these two exponent properties, then here we have 5 to the power of 1 times 5 to the power of x, plus here we have 5 to the power of 1 divided by 5 to the power of x. This is equal to 26. Now, the next step from here, we can let 5 to the power of x be equal to u. So that now, here we have 5 multiplied by u, then plus 5 divided by u. This is equal to 26. So here we have 5u, then plus 5 over u. This is equal to 26. So that now 5u, this is a whole number, so this is over 1, and 26 is a whole number, so this is over 1. So let's multiply both sides by u, multiply here by u, and also here by u. So that now here we have 5u squared, then plus u and u here simplify, so we have 5. This is equal to 26 times u, so this is 26u. So we have 5u squared, then let's take 26u on the left hand side, so this becomes minus 26u, then plus 5. This is equal to 0. Now, this is a quadratic equation of the form au squared plus bu plus c. This is equal to 0. From this quadratic equation here, we have a is equal to 5. Then we have b is equal to minus 26. And that c is equal to 5. Now, to solve for u1, u2, we apply the quadratic formula, that's minus b plus or minus the square root of b squared minus 4ac, everything here divided by 2 times a. So that now, let's substitute the values of a, b, and c. We have minus 26, cross the parentheses here, plus or minus the square root of, now we have minus 26 raised to the power of 2 minus 4 times a, which is 5, then times c, which is also equal to 5. Everything here divided by 2 times a, which is 5. So here we have minus times minus 26. This is plus 26 plus or minus the square root of. Now we have minus 26 squared. Minus 26 squared, this is actually 676. Then subtract 4 times 5 here is 20 times 5. This is 100. Divided by 2 times 5, this is 10. So here we have 26 plus or minus the square root of. Now, 676 minus 100, this is the same thing as 576 divided by 10. So here we have 26 plus or minus the square root of 576. This is equal to 24 divided here by 10. So this implies that u1 is equal to 26 plus 24 divided by 10. So 26 plus 24, this is equal to 50 divided by 10, and this implies that u1 is equal to 5. Now let's do for u2. u2 is equal to 26 subtract 24 divided by 10. So this implies that here 26 minus 24, this is 2 over 10. So we can simplify here by 2, 1, 5 divided by 2, this is 5. So u2, this is equal to 1 over 5. Now we have u1 is equal to 5, u2 is equal to 1 over 5. So now, if you recall, we are saying that let 5 to the power of x be equal to u. So now let's do for x is here. Let's start with u1. So we have 5 to the power of x. This is equal to 5. So 5 is raised to the power of 1. Since the bases are common here, that is a to the power of n, this is equal to a to the power of m. The bases are common here, then exponent n is equal to m. So applying this property, then x is equal to 1. That is x1 is equal to 1. Now, let's proceed to u2. Remember 5 to the power of x, this is equal to u2. u2 is 1 over 5. Now, given that 1 over a, this is the same thing as a to the power of minus 1. So applying this property, then we have 5 to the power of x. This is equal to 5 to the power of minus 1. Again here, the bases are common here, so we can apply this property, and this implies that x is equal to minus 1. This is x2 is equal to minus 1. So the next step here is to verify. So let's verify that x1 and x2 satisfies the equation. So if you recall, we have 5 raised to the power of 1 plus x plus 5 to the power of 1 minus x. This is supposed to give us a value of 26. So let's substitute x1, which is 1. So here we have 5 to the power of 1 plus 1, then plus 5 to the power of 1 minus 1. This is supposed to give us a value of 26. So here we have 5 to the power of 1 plus 1, this is 2. So this is 5 squared, then plus 5 to the power of 0, this is 1 minus 1. This should give us a value of 26. So 5 squared, this is 25, plus 5 to the power of 0, this is 1. This is equal to 26. So 25 plus 1, this is 26, and this is equal to 26. So the left-hand side is equal to the right-hand side. So this implies that x1 satisfies the equation. Let's check x2, which is minus 1. Again, we have 5 to the power of 1 plus x, then plus 5 to the power of 1 minus x. This should give us a value of 26. So substituting x, here we have 5 raised to the power of 1 plus minus 1, then plus 5 to the power of 1 minus into the parenthesis minus 1. This should give us a value of 26. So this is 5 to the power of 1. Here we have plus times minus 1. This is minus 1. Then plus, here we have 5 to the power of 1. Minus times minus 1. This is plus 1. This is supposed to give us a value of 26. So we have 5 to the power of 1 minus 1. This is 5 to the power of 0. Then plus, this is 5 to the power of 1 plus 1 here. This is 2. And this should give us a value of 26. So we have 5 to the power of 0. This is 1. Then plus 5 to the power of 2. This is equal to 25. And this is supposed to give us a value of 26. So this implies that 1 plus 25, this is equal to 26. and this is equal to 26. The left hand side is equal to the right hand side, and this implies that x2 satisfies the equation. So kindly follow the steps, like this video, and subscribe. See you in the next video. Bye bye for now.